Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. Jupiter's moon, Io. One of the most visible of Jupiter's four largest moons that can be seen with a telescope and/or binoculars is the moon called Io. With a radius of 1,131.7 miles in diameter, Io is the most volcanically active body within our solar system. Io has a slightly elliptical shape, with its longest axis directed towards Jupiter. Among the four visible satellites of Jupiter, Io ranks third behind Ganymede and Callisto, but ahead of Europa in both mass and volume. Io's average orbital distance from Jupiter is 262,000 miles. Io takes 1.77 Earth days to orbit Jupiter, being tidally locked with the same side always facing Jupiter. Plumes of sulfur spew upward as high as 190 miles from the moon's surface, with its whole surface splotched with lava lakes and floodplains of liquid sulfur rock. The interior of Io is composed of an iron sulfide core, with a brown-colored silicate outer layer. This gives Io a splotchy orange, yellow, black, red, and white appearance. Io formed in a region around Jupiter where water ice was plentiful, at that time billions of years ago. However, over time, Jupiter's intense radiation field removed all the existing water from Io's surface. The moon's most prominent geological surface features are its volcanoes, with Io being the only known volcanically active body in the solar system, aside from Earth. Io's volcanic activity results from the moon being compressed and then stretched because of Jupiter's gravity, with Io's orbit around Jupiter. Based on Io's volcanic activity, its atmosphere contains mostly sulfur dioxide. Magnetic forces from Jupiter's rotation strips away the amount of a ton of Io's surface material every second. This stripped material from Io becomes ionized, forming a donut-shaped radioactive cloud of material circling around Jupiter. Some of the ions within this material are pulled into Jupiter's upper atmosphere, creating auroras. Also, the sulfur dioxide produced freezes when the moon's orbital position is directly behind Jupiter. When Io swings back around from behind Jupiter into the sunlight, the frozen sulfur dioxide converts back into a gas. Io has its share of tall mountains, pits of various shapes and sizes, with lava flows representing the major volcanic terrain on its surface. Magma erupts onto the surface through vents and fissures, with newer sulfur lava flows covering the older flows. These constantly produced sulfur lava flows are what keeps the surface of Io almost free of meteor impact cratering. Despite volcanism being the dominant force on Io's surface, its mountains are tectonic in origin, not volcanic. The continuous compressing and stretching forces at play within Io's lithosphere is what leads to its building of mountains. Io's mountains, which average 3.7 miles in height, are isolated structures with no apparent global tectonic pattern. All of Io's mountains are in different stages of degradation. The reason for this comes from the geological effect known as mass wasting. It is the primary form of mountain degradation on Io. Thank you for watching, and I hope you enjoyed this video about the geology of Io.